Remember this example, video 33b, where we were given a position function for a particle f of t equals 10t minus 1.86 t squared. We were asked to find the average velocity when the initial time we called a equals 1 second and the final time was 1.5 seconds. Now I'm just interested in reviewing step 1. We were asked to simplify the expression for the average velocity using this particular function, f of t, and this particular a value, 1. So we use the function to evaluate f of a plus h minus f of a over h, and then we plugged in a equals 1, and when we completely simplified, our final expression for this function, the average velocity, was 6.28 minus 1.86 h. Okay, now keeping that final formula in mind, let's move to a different idea. Adjusting the screen. We're going to do the same problem that we did earlier, but using a different formula. To find the instantaneous velocity at t equal a, just take the limit as the amount of the elapsed time goes to 0 in this average velocity formula. Example, we estimate the instant velocity at time equals t equals 1. By using v at t equals a, which in this case will be 1, is a limit as h approaches 0 of f of a plus h minus f of a over h. So you remember what h is. That's the difference between the initial and the final t values. So if we let that difference between the t values collapse to 0, then we will have the velocity at an exact t equals a instead of a range between initial t and final t. That's why we're letting h, the difference between the t values, go to 0. Okay, let's use the formula that we developed back in example 33b, which I showed you earlier in this video. And let's use a equals 1, which we already used in the previous formula. And all we need to do is let h go to 0. So the v at t equal 1 is a limit as h approaches 0 of 6.28 minus 1.86 h. Let the h go to 0, you get 6.28 minus 1.86 times 0, which is 6.28 meters per second for the instantaneous velocity at a equal 1.